What is a number? Greetings and welcome to the new math channel. In the last video, we derived the fifth requirement of Euclid's Elements, which states the sum of co-interior angles is constant on either side of the transversal. Here's a quick review. We can summarize the fifth requirement as follows. If the lines are parallel, then we are done. We already know that the co-interior angles have a sum of two right angles. If the lines are not parallel, then we know that a triangle is formed on the side of the transversal where the non-parallel lines meet. Given that the angle where the lines meet does not change, it follows that the sum of the remaining angles is constant on either side of the transversal. In this video, we will systematically derive the concept of number. First, what is a magnitude? A magnitude is the idea of size, dimension, or extent. A magnitude asks these kind of questions: how tall or short, heavy or light, near or far, big or small, dense or sparse. The answer to these questions requires a measurement of some type. Here are the following length magnitudes. By looking at these, we can visually discern the following for certain. This is called a qualitative measure. It is not easy to tell if C and F are different unless we could overlap the one line with the other. If we can tell the lines are different, then all we can say is which is shorter or longer, but not by how much. This is called qualitative trichotomy. Aside from knowing about trichotomy, we next want to know if in any given ratio the line lengths have a further relationship, such as proportion, which is a consideration of the ratio parts in terms of the whole. In other words, we realize the concept of unit, and we want to know what is each length in terms of a chosen unit. If we can measure each part of the ratio using the unit and/or equal parts thereof, then we can name the measure of the antecedent by writing numerator or denominator. Suppose we tried to find how much bigger B is than A. We would attempt to measure B using A, the smaller measuring the larger. So A measures B exactly, but by how much? Let's define a ratio of magnitudes as follows. The short line is called the antecedent and the long line is called the consequent, which literally means A compared to B. We choose A as the standard of measure by defining the unit ratio. We will call this by the name of unit or 1. A measures itself exactly. Next, we will consider all ratios whose consequent is the shorter length and whose antecedent is composed of the shorter length. Now, to represent this ratio, we can write this ratio, or 1:5. We call this a ratio of numbers. If we wished to measure the shorter length with the longer length, then we would have this ratio, or 5:1. As you can see, provided both the antecedents and consequents consist or are composed of the same unit, we now have a way to represent any number that is represented by ratios, and this is how rational numbers are derived. Note that a magnitude is not the same as a number. This ratio, or 1:5, is a ratio of numbers, hence a rational number. There are no other numbers. In the event of a magnitude that is not composed of the unit or any part of the unit, such a magnitude has no measure and is called an incommensurable magnitude. A number is defined as the measure of a magnitude. The concept of number has been derived. In the next video, the concept of equivalence and equivalent objects will be derived.